Determine if the following series is absolutely convergent, conditionally convergent, or divergent. We have sum n from 1 through infinity of negative 2 raised to n over 2n plus 1 factorial. Let me rewrite this series. So we have sum n from 1 through infinity, negative 2 raised to n. Okay, negative 2 is same as negative 1 times 2, and I can separate into 2. So this is negative 1 to the n times 2 raised to n over we have 2n plus 1 factorial. Okay, and negative 1 to the n, so we have an alternating series. Now we want to check if it converges absolutely, or converges conditionally, or diverges. Okay, since this series has this factorial 2n plus 1 factorial, we want to use the ratio test. Okay, we want to find an means this term, the generic term, whatever we have after this sigma sign. So negative 1 to the n 2n over 2n plus 1 factorial. Then we can find the next term an plus 1, which is needed for the ratio test. The next term, just replace n throughout by n plus 1. So this will be negative 1 raised to n plus 1, 2 raised to n plus 1 over 2n. n will be now n plus 1. So this will be 2n plus 1 plus 1 on the bottom. 2n is being replaced by n plus 1. So we have 2 times quantity n plus 1 plus 1. And we need to distribute 2. So we get 2n plus 2 times 1 2 plus 1 3. So 2n plus 3 factorial. That's the next term. Now using the ratio test, we take the following limit. Now limit of absolute an plus 1 over an as n goes to infinity. Okay, which is limit n goes to infinity of absolute value of an plus 1, which is here. So negative 1 raised to n plus 1 times 2 raised to n plus 1 divided by 2n plus 3 factorial divided by an. Okay, an plus 1 is this, divided by an. So that means multiply by the reciprocal of an. So here is an. So we are supposed to divide. I am multiplying by its reciprocal. So 2n plus 1 factorial goes on the top, and negative 1 raised to n on the bottom, 2 raised to n on the bottom. We have absolute value. Okay, now we take the absolute value in the next step. That means the output should be all positive. So negative 1 raised to n plus 1 is producing positive 1, negative 1, positive 1, negative 1. But when we take the absolute value, it's gonna go to just 1, positive 1 all the time. Same thing here, it's gonna go to positive 1 all the time. So we can ignore these two terms because 1 times anything is that thing. Okay, and rest of the factors are all positive, so we can safely remove the absolute value. So this is same as the following limit. Limit n goes to infinity of 2 raised to n plus 1, that's on the top, times 2n plus 1 factorial, that's on the top, divided by 2n plus 3 factorial times 2 raised to n. Now we need to simplify this fraction because we can cancel a lot of things here. So this fraction is same as limit n going to infinity, 2n plus 1 and 2n. Okay, as we know, 2 raised to n plus 1 is same as 2 raised to n times 2 raised to 1, which is 2. Okay, so 2 raised to n plus 1 is 2 raised to n times 2, so that we can cancel 2 raised to n, 2 raised to n once we factor in this way. 2n plus 1 factorial, 2n plus 3 factorial. So 2n plus 3 is bigger, so I want to expand this. So this is just 2n plus 1 factorial on the top, everything divided by, so let me write 2 raised to n here, 2n plus 3 factorial. So let's work on here, 2n plus 3 factorial. By definition, 2n plus 3 times 1 less, so 2n plus 2 times 2n plus 2, 1 less, so 2n plus 1 times 1 less, 2n, etc., etc. And we can stop at 2n plus 1 factorial. So this factor, and 2n plus 1 factorial. Okay, we can always do that. It's like, let's say if we have 9 factorial, that's same as 9 times 8 times 7 times 6 4 5 3 2 1, but we can stop here, 7 factorial, 9 8 7 factorial. Factorial means 7 times 6 times 5 4 3 2 1. Same thing here, 2n plus 3 factorial is 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. We stop here because we have same thing on the top, so that we can cancel. So 2n plus 3 factorial is 2n plus 3, 1 less 2n plus 2, and 1 less 2n plus 1, and we can put factorial 2n plus 1 factorial, and we had this 2 raised to n on the bottom. Now 2n plus 1 factorial, 2n plus 1 factorial cancel, and 2 raised to n, 2 raised to n cancel. Then we have now limit n goes to infinity of only 2 on the top. On the bottom we have, we don't have to multiply, 2n plus 3 times 2n plus 2. Okay, and when n goes to infinity, the bottom goes to infinity, but top 2 is fixed. So 2 over infinity, which is 0. So the limit is 0, which is less than 1. Since this ratio an plus 1 over an is less than 1, the series converges absolutely. So the series converges absolutely, and done. So converges absolutely means the series also converges as well. Okay.